For this question, the thing to remember is a line and a plane can either intersect at a point, or rather can either intersect or are parallel. So that is, if the minimum distance is not 0, then the line and plane are parallel. So starting with this, let's dive in. So we have been provided with two lines. X is the set of all the planes that contain the line L1. The line L1 is lambda times I plus j plus k cap. So all the points of the form lambda comma lambda comma lambda. So ax plus by plus cz equals to d is a general equation of a plane. So this line lies on this plane, that means 0 comma 0 comma 0, or the origin lies on this plane, which gives us that d is 0. Then we are left with, when lambda is non-zero, we are left with lambda times a plus b plus c equals to 0, which gives us that a plus b plus c is 0. So we have our first constraint. So this is the family of planes x. X are all the planes of the form given that a plus b plus c is 0. And a comma b comma c are in R, obviously. So yeah, moving next. We have R2. So we are dh denotes the smallest possible distance between the points of L2 and H. So as we see, as we just saw, the thing is that if the smallest possible distance is not 0, then the line L2 is parallel to plane H from X. H0 be a plane in X for which dh0 is the maximum. So if dh0 is the maximum, that means dh0 is non-zero. That gives us that h0 is parallel to the line R2, line L2. So h0 in X is the plane parallel to L2, because dh as h varies from X can either be 0 or the plane H is parallel to X. So h0 is the plane from the maximum distance, plane of the maximum distance from the line L2. So h0 must be parallel to L2. So that gives us a x plus by plus cz. Let h0 be the plane. We already have a constraint. We already have this constraint. The another constraint we have is that the line should be parallel to the plane. The line is along the vector 1 comma 0 comma 1, and if it's parallel to this plane, that means it's perpendicular. This vector is perpendicular to the vector normal to this plane, and we know the normal vector is this, or rather this vector is normal to this plane, which means this vector must be normal to this vector as well. That means the dot product of these two vectors must be 0. Dot product of these two vectors must be 0. That gives us a into 1 plus b into 0, that's 0, plus c into 1 is 0. So we have the equation of h0, b a plus c is 0, that gives us b is 0. For h0, b is 0. So we have ax minus z equals to 0, or x minus z equals to 0 is the equation of our plane h0. So we have h0 x minus z equals to 0, and as the line L2 is parallel to this plane, then to find the distance between the line and the plane, we can take any point on the line. So we'll take 0 comma 1 comma minus 1, and we'll find the distance of this from this plane. So that simply becomes 1 by root 2. Why? Because the distance of point A comma B comma C from, or rather P comma Q comma R from plane A comma B comma C, or from plane AX plus BY plus CZ equals to D is given by AP plus BQ plus CR minus D mod upon. Right. So substituting this and this in this formula, we get the distance to be 1 over root 2. So the value of dh0 is 1 by root 2. So P is 5. The distance of the point 0 comma 1 comma 2 from h0 is root 2. We're again using the formula, aforementioned formula. Distance of origin from, so origin lies on this plane, so the distance is 0, so it's 3. And as distance of origin from the point of intersection of planes x equals to 1, that gives us z equals to 1, that gives us y equals to 1. So the point of intersection of these planes with h0 is 1 comma 1 comma 1, and the distance of origin from this point is root 3. So that's 1. So this is the answer.